Good afternoon, everybody. Thank you for joining us in this webinar on the governance and innovation in aquathermal systems, challenges and success factors. This event is part of a series of webinars organized in the frame of the WaterWarmth project, a pioneering initiative under the Interreg North Sea program. The project runs from June 2023 to September 2026, and it brings together 20 partners from 6 countries: Belgium, the Netherlands, Germany, France, Denmark, and Sweden, to accelerate the deployment of aquathermal energy. Aquathermal energy harnesses the heat stored in surface water, such as rivers, lakes, and even coastal water bodies, using heat exchangers and heat pumps to provide sustainable heating and cooling for buildings. The project aims to demonstrate how this underused fossil-free resource can power energy communities, going from local to cooperative systems that keep energy production and decision-making in the hands of citizens. Through a series of real-life pilot projects, policy research, and tools such as the QuickScan tool for assessing aquathermal potential, this project will generate practical guidelines and a roadmap for scaling such systems across the region. In case you've missed our previous webinars and you're curious, you can go to our YouTube channel to watch the recordings and also check out our project websites. I will leave both links in the chat soon. And if you're interested in our next events, please follow our LinkedIn page or subscribe to our newsletter to never miss our updates. But let's move on to today's webinar agenda. So right now, I am giving the introduction. I'm Martina Battocchio, the EU Projects Officer at the European Heat Pump Association, one of the partners of this project. We will soon move on to the first presentation on the WaterWarmth project updates done by the project leader, Dirk Blom. And then we will have a presentation regarding governance in action, challenges and opportunities for developing and scaling aquathermal energy in the North Sea region. A case study tour on the pilot sites developed by the project. And our last presentation will be on the spotlight on feasibility of aquathermal energy. We will finish this webinar with a Q&A session. As you may have noticed, both your camera and microphone are disabled to avoid any disruptions. You can leave your questions in the chat or in the Q&A section at any point during this event. Just to make sure that you indicate the speaker you are addressing. During the session, at the end of our webinar, I will take care of reading your questions to the different speakers so that they can provide you with an answer. So we can now start with the first presentation on the WaterWarmth project updates. Done by Dirk Blom. Dirk is a driven project leader for the province of Friesland with a focus on the regional heating translation. With a background in public administration, he knows how to connect the dots between governments and working efficiently towards scalable solutions within the heating transition for communities. Aquathermal energy, sustainable local industries, community-led energy initiatives, and district heating are the primary topics in his portfolio. Dirk, I leave you the floor for your presentation. Thank you.
Yes, thank you, Martina, for the nice introduction. Let's go. WaterWarmth status update. So actually, Martina already told something about the project short. And I have to correct you there for something, Martina, because we started indeed in July 2023, but we are finished in March 2027 due to a successful apply for an extension of the project. So we actually have some more time for our activities within the project. As said, the province of Friesland is a lead partner for this project. We're with now with we started with 22, but we're with 19 organizations from 6 different countries. As you can see on the map on the right, we have partners differing from universities to consultancy bureaus to research parties to local governments. We ourselves are a regional government, and there are some other interesting parties within our consortium. We have a budget of over 7.9 million euros. That's quite a lot, and you will see soon why we have such a big amount of budget for our project. But first, the main objectives. So WaterWarmth, like the title says, it's a project that evolves around aquathermal energy. Aquathermal energy is a technique to extract heat out of surface water, but you can also include heat out of wastewater or drinking water even. And we are using that water to heat and cool, because you can either heat buildings in the winter, but you can also passively cool them during the summertime. Next to that, we're having also a quite a large focus on energy communities, because as of now we see they struggle quite a lot to get their projects up and running. So that is it's a main target group within our project. And as Martina said, we're also building pilots, and we're aiming to use them as leading examples for others to get inspiration from, and kind of see for themselves how it is applicable for their own situation. Go to the next. So don't get distracted by the complex structure. This is merely an overview of which work packages we have within WaterWarmth. So the first one is mainly on the potential of aquathermal energy. So looking into where could we fit in aquathermal energy installations. The second one is the pilots. So those are small scale, as we call them. So with a few connections and implemented within the lifetime of the project. The large ones are within work package 3. Those aren't developed within work package 3s within the lifetime of the project, simply because they are too big and too massive to realize within a short amount of time, so to say. Normally they take around 8 to 10 years, so that's quite a large time. Next to that, we also look into like the theoretical optimization of energy systems to make them work more efficient, and also integrate the aquathermal energy systems with energy and electricity. And in work package 5 and 6, we're mainly looking at more kind of the policy strategy on governance, and like the economical impact and the social and environmental impact, and how it could make a positive impact on our energy and heating transition. More on that later in this webinar. So a short overview of the highlights per work package. So mentioned the pilots. In work package 3, we're doing feasibility studies to see whether or not large scale sites could be feasible and also scalable towards other project ideas in other certain areas of Europe. Another thing that we are doing is we are calculating the socio-economic potential for the whole North Sea region of Europe. So actually, we divided it in 39 NUTS2 regions, and we give an estimated overview of the potential of aquathermal energy in comparison to, for instance, gas or oil. All right. So these are the I hope you can read it. It's quite a sharp, bright light. But actually, what we are in terms of products, what are we working towards to is the quick scan tool. We already did a webinar last time on this one. Hope you have visited, and otherwise you can always download the quick scan tool because it's available on our website. We are also looking into building a roadmap for project development to make clear for every project developer which steps need to be taken from project idea to maintenance and maybe a next project. And last thing worth mentioning is that we're also trying to reach more than 52 organizations and involve them in our project and see if they can take things up from our side and implement them in own projects. So that was it was not quite short, but it was a recap. Where are we now? So as said, we have a quick scan 1.0. We're also aiming for a 2.0 version. So indeed, download the quick scan tool. Thank you, Martina, for the link. Next to that, we have already a report on governance structures. We have a report on smart aquathermal integration from work package 4. We have a report on what main opportunities and barriers projects are facing right now. So this is mainly based on practical experience. We also do something that's called podcasting. We do this with the Danish Board of District Heating, which has a broad network, and we have really big outreach to other organizations. We have some pilot videos, and we have the website, and I will happily show you one of our pilot sites right now with one of the videos. It's the one in Kortrijk in Flanders, Belgium, and they're explaining what kind of project they have, why they did it, and for your background information, it's a campus for mainly for students, but it's also used for housing. And I think I should just do this. So this is one of our pilot sites, which is we've been here last week, and it's in further development, and it will be ready hopefully in beginning of next year. This was just one of our videos. We have made one for each pilot of them, plus the large scale site. So there should be 10 videos available right now if you're interested in our other pilots. So where are we at right now? Which things are we developing? So, as said before, we have feasibility studies. Some of them are already done, and we'll develop action plans out of them, also to map what has been done, what choices have been made, and where do we want to go to. So this could be useful for other projects as well to map these kind of things. We are also developing a vision for aquathermal energy for 2050, and correct me later on if I'm wrong, but that's for the whole North Sea region, on aquathermal energy, how it could be used in future energy systems, and how it could have a positive impact. And as said, economic potential will be developed. We're also developing a modeling tool for energy systems just to optimize aquathermal energy systems into electricity grids. And last but not least, we're also looking into the role of aquathermal energy and what positive impact it could have on energy security and independency. Let's see, I think this should be my last one. So what's next? The roadmap will be built. We are working towards an energy management strategy. We will have 5 to 6 operational pilot installations by the end. Maybe one to keep in mind is that we are also aiming for 2 larger publicly open events. One in Ghent in May or June. I mentioned here June, but it could be May as well. We did not yet decide it, but on that event we are presenting all the work we have done until now in terms of products, in terms of cooperation. Also, other European projects will be attending here and presenting their works. And we are also cooperating with the EHPA on having a policy event in Brussels in September, also aiming to attract more kind of the business side of the heat transition and the European policymakers, national policymakers, with a small event prior to the EHPA annual forum. And of course, we'll do some more podcasting and videos. All right, thank you. That was it. So questions will be later on, and I think we go to the next one. So, yeah.
Thank you, Dirk, for the presentation. And as you mentioned, any questions for you can be left in the chats, and I will read them out during our Q&A session at the end of the webinar. We can now move on to our next presentation on governance in action, challenges and opportunities for developing and scaling aquathermal energy in the North Sea region. We have 3 speakers for this presentation. The first one is Dr. Natabi Molakwana, who is a researcher in the Faculty of Technology, Policy and Management at Delft University of Technology. She has over 20 years of experience in research focusing on energy policy implementation, energy poverty, energy access, as well as gender mainstreaming in the energy sector. Her research at the Technologische Universität Delft focuses on energy transitions in the focus on energy communities and the governance of energy systems. The second speaker is Anne-Sophie Mikalev-Nilsson, who is a project assistant at Lund University. She holds 2 master's degrees in environmental science with a focus on management from the Swedish University of Agricultural Sciences and the University of Hohenheim. She also holds a Bachelor of Science in Ecological Technology from Mid Sweden University. Her fields of interest include energy transitions in both the global north and global south, the gendered implication of climate change, and sustainable transitions. She has experience in systemic research on how labor-saving technologies influence economic conditions and women's empowerment in the global south. And our third speaker is Thomas Oppe, who is a professor of sustainability of rural urban systems at the Department of Technology, Policy and Management in the Faculty of Behavior Management and Social Sciences at the University of Twente in Enschede, the Netherlands. His research line is on governing complex sustainability transitions in regional settings. Within his research line, Thomas is particularly focused on governance of green energy transitions. I will now leave the floor to Natabi. Thank you.
Thank you, Martina. And I'd like to also welcome everyone and thank you for your time in joining our webinar today. Okay, I'm taking control. Can you see my screen properly, Martina? You can.
Yes.
Great, thank you. Okay, so I'll be presenting on Work Package 6, the work that we have been doing in the past few months. So Work Package 6 consists of, is made up of the Delft University of Technology, that's where I'm sitting, our partners in Lund University and the University of Twente. So this presentation is based on the barriers and the opportunities that we have found in the implementation of aquathermal energy systems. So we completed the research project or the research report in March, and this was based on the interviews that we conducted with the 9 pilots that we have in our research project, plus another partner or a former partner that used to be also part of the project, and that was the WaterWarmth Energy Cooperation in Friesland. So we conducted interviews with everyone concerned, everyone that is implementing the pilots, and we did the analysis as well. So first, just to take you through what we did in terms of the questions that we asked. The questions, you know, as we're all based at the universities, were guided a lot by theoretical frameworks. I'm not going to dwell too much on this, but just to give you a background of how we came about with the questions that we asked to all our pilot leaders. So we're using 3 theoretical frameworks for our work: the strategic niche management, the governance arrangements, and the multi-level perspectives. So under the strategic niche management framework, we ask questions that are concerning visioning. So these were concerning how the different pilots had their visions, what kind of expectations they had in starting their projects, and in what ways was learning organized, and also questions about the network formations within their projects. Also, we asked about, in terms of governance arrangements, what were the most important regulatory frameworks that they were using or that affected their projects the most. But most important for this particular presentation is the questions that we put together under the multi-level perspectives framework, where we were asking about the most significant challenges that the pilots had come across while they were trying to implement their projects. Also, most important as well, what were the good practice lessons? So what were the successes that they learned along the way? Going into the challenges, so we stated the challenges as barriers because these were seen as the difficulties or hindrances in implementing the projects that our pilots were trying to implement over time. The most important one that came up was the policy and regulation barriers. So the lack of policy regulation and direction on energy technologies, that was quite difficult, because without that policy and regulation, it was quite difficult to make decisions or go ahead with this new technology of aquathermal energy. Also, not having an internal vision as a project was also quite difficult, because without a clear framework, especially at the beginning of the project, it was quite impossible. Even the partners that did have a clear framework, it was quite clear that they had to be constantly updating it because of the challenges that they were facing on the ground. The challenge of government support of fossil fuels meant that the aquathermal energy stood very little chance in terms of competing with fossil fuels. So these subsidies, of course, are influenced by geopolitics and internal context, depending on country to country. But these were standing or are standing in the way of funding renewable energy technologies, and especially new innovations that are coming up, such as the aquathermal energy. And there's also a reluctance in accepting aquathermal energy from different stakeholders or players or actors in the field of energy. So there's quite a lot of skepticism from policy and decision makers about this new technology. And this was told to us by the pilots about, it's quite difficult to also explain and let the potential stakeholders to see what the benefits of aquathermal energy is, because there's quite a lot of reluctance. It's a new technology that they are not used to, they've never seen before, they don't know how it will work, and in terms of putting money or changing policy based on that, it was quite difficult for them. Another challenge was the issue of information, withholding information. There was lack of free flow of information between stakeholders. Again, the newness of the technology and the new ways of working with this new technology meant that people were not familiar with it. And, once information is generated, what knowledge is generated, some people felt that they needed to hold on to that and protect it instead of sharing it, which would lead to learning for more stakeholders. There's also a barrier of lack of public awareness. This is also related to the barriers that I've mentioned before, because it leads to indecisiveness about aquathermal energy as a viable option. So you can imagine a scenario where you try to convince households about changing to aquathermal energy. If there's not enough public awareness on this technology, or of course on any technology, it's quite difficult to convince people to buy into it. So this lack of public awareness is one of the barriers that we're seen to be, standing in the way of acceptance. The lack of financial support was also noted, and we have seen how that is quite critical and quite important for this kind of projects. So insufficient access to funding at critical project stages. Actually, all the stages in this in aquathermal energy implementation are critical from beginning to full running and operation. And we've seen this with some projects that have had to stop because there's just not enough financial support for them. So insufficient access to funding is one of the most critical issues that needs to be looked at, and a barrier that needs more attention. The high technical and operational costs, it's also related to the funding issue. So at all stages of the project development, the costs are quite high. We have seen with some of the pilots in our project whereby at the beginning of the project, the costs were predicted to be a certain amount. And as the project took off, all those costs changed. And luckily, our project was quite flexible in terms of how you can move the funds to accommodate that rising cost, because in most cases this was very much unexpected, and so it meant that the funding aspect of it has to be very flexible in order to accommodate these high operational costs. Also, the high costs were also because not only of the equipment, but also because of change in technology, or where you find that the installation does not take place in the place where it was meant to take place, and it has to be moved to somewhere else. All of that is costly, and you need flexibility in that. So the high technical and operational costs also form part of these barriers. The other barriers are also lack of expertise. And also this, I think the contributing factor is that this is a new innovation. So a lack of expertise leads to project delays and incorrect decision making. You're dealing with stakeholders that are not familiar with the technology. You're dealing with policymakers that are not familiar also with the way that the technology is working, or also not knowing what will the end product look like. So lack of expertise also lead to, hindrances in the implementation because there's just lack of knowledge. So it's a kind of learn as you go type of process, which also takes us back to the need for flexibility when working with this technology. Project delays, we also saw that in our pilots, whereby there are difficulties in controlling timing of various project activities because of several factors that may contribute to the project delays, like not finding the right project management team in time, the procurement process taking longer than expected. Also, the contribution of the funding issues is also a contributing factor. So we also found, successes and enabling factors to aquathermal implementation as well. So it was not all bad news. And the process that the pilots were going through also gave them some good experiences. And also because we're working with teams that also, have been working with this technology for quite some time. But one of the successes was that the political regulations and government support was quite important. It was seen as important. And working closely with government stakeholders from the beginning of the project was seen as very critical, because that helps you to kind of have the policy influence in a way, and influence those high-level stakeholders from the beginning of the project, letting them know what you are working on, so that they are also, when it comes time to readjust the policies and regulations, they also have the experience of what that is needed for. A critical issue also that leads to success of these projects is the project preparation. In fact, our pilots, really, all of them were expressing that it was quite important to have a clear vision, and early feasibility studies are key to the success of this project. So giving yourself time before the main implementation of the project to have and conduct pre-feasibility studies, and the main feasibility studies is quite key. And we have seen from our pilots that they learned a lot of lessons from that, from issues like water temperature and the equipment that is needed and the permits that are needed. So preparing the project at all these levels was quite key. And this also is one of the enabling factors for better implementation. The network and stakeholders. So having people that speak the same language in terms of the needs of the project. So having formal agreements with all project stakeholders was also seen as key, so that everyone knows what their expectations are and what they are going to get out of the project. So having a good network so that, you can also learn from them was seen as quite one of the issues that lead to success. Communication. with stakeholders, which contributes to clear understanding of the project by us, by all stakeholders, and everyone that is involved in the project was also seen as one of the key things that lead to success of the project. So communication, so keeping the lines of communication open all the time so that people have the information that they require all the time to make the important decisions regarding the implementation process. Also sharing experiences. So our pilots were saying that having this project, this WaterWarmth project, was quite important for them because they could learn from each other, share experiences. We have pilot projects in the Netherlands, in Belgium, in France, in Denmark. And those, depending on the location, of course, the experiences are different. But there are certain things that we can all learn from, by talking to each other, learning how others are doing. So that was quite helpful. So beyond the WaterWarmth project as well, people were looking at other experiences in other countries that have done and implemented aquathermal energy for longer than what our project partners have done. An enabling factor is also financial support and funding flexibility. I've touched a bit on that because securing flexible funding for budget restructuring is quite important, and we have seen that also with our project where budget restructuring and having that flexibility and not having a rigid budget or rigid budget holders was quite important because things happen, prices change, and the other needs arise as well that need for better financial support and funding flexibility. So I'll stop here for now and hand over to Anne-Sophie to carry on with the presentation. Thank you.
Great. Thank you, Natabi. So before I start, I'll just say hi. My name is Anne-Sophie Nilsson. I'm sitting here in Lund. And we have now, going into the presentation, Natabi has now shown us the barriers to aquathermal energy implementation along with its successes. But what I would like to present to you all very briefly today is to describe our most recent online partner workshop held by us in WP6. Why do I want to show you this? I think it gives a good example of how we work and how we work within this WaterWarmth project. So the Barriers and Successes Partner Workshop. This was an interactive process between us in VP6 and the WaterWarmth partners to validate our results of barriers and successes, which Natabi has just presented to you. But more than validating our results, we also wanted to use this workshop as an opportunity to give the WaterWarmth participants more input if they agreed with our results or not, and find any emerging patterns or ideas about barriers and successes. So what was our goal for this workshop? It was to compare and validate the results of successes and barriers during this online process. So the diagram that you see here to the right shows the build-up or the methodology behind the idea of this online workshop. We see that the results from May 2024, barriers and successes, and November 2024 really built up to this X, which was our workshop, the barriers and successes online workshop. So now I've been talking about what this workshop is meant to do, but what did it actually look like? So on the right, we see the online layout. If anyone recognizes it, we can see that it was held on Miro. And we had 10 groups. And this example on the right shows the individual pilot example. So you can see what the pilot level it looks like. This was the pilot example of Die Friske Maren. I apologize for any of our Dutch speakers. But you can see that we had 10 groups made up of our 9 pilots, and the 10th or final group was the Warmheg Energy Cooperative, who are no longer associated with the project. But within this zoomed in view, let me explain what we asked each pilot to do or participate in. We provided the pilots with the results of the barriers and successes from the May and November results, which can be found in blue and green. So when the pilots entered this online session, the final spot or the yellow boxes was left completely blank. So this allowed the pilots to review the previous results and give their new input. We then analyzed this to see if any new patterns emerged or if there were any differences between what was found and what they thought. Why did we choose this approach? This was a very effective method to allow the pilots, each individual pilot, to review their previous results and gain new insights. It was also the best method we chose for an online workshop with a limited time frame, which is why we chose this one. So this was a very, very brief overview into our workshop, but I hope you have a better understanding of how we work within BP6 and how we analyze the successes and barriers. So with that, I will hand it over to Thomas, who will continue with our conclusion. Thanks.
Thank you, Anne-Sophie. Let's move on to the conclusions about aquathermal energy governance, addressing the good, the bad, and the possible. We have some great number of pilots going on, but the next challenge is to scale them up, to scale them out, to scale them deep, to scale them in between. And to expand the niche and the eventual adoption of aquathermal in the heat systems in the North Sea region in Europe. Let's start with some positive developments. First,
can I interrupt you for a second? I think the presentation has stopped, but I'll let Martina put it up again. I'm sorry.
Yeah, but maybe I can just continue my story and then the people can see the slide afterwards. Some positive developments is what we noticed, that basically following the Paris Agreement, increasing attention to sustainable energy transition, also sustainable heat transition across Europe, also in the North Sea region. And in countries like the Netherlands, you see that there is attention to this. And then it's basically coined into a meta-governance framework called the Climate Agreement. At the same time, there was a big problem in the country, earthquakes in the north, where the natural gas basically comes from, outside import from Russia. But that's another factor why heat becomes more important, also with prices going up. But that also leads to the so-called start of the heat transition. And also regional implications. In the Friesland province and region, for example, there was more attention to the WaterWarmth. And we're having a lot of aquathermal potential, a lot of lakes from which basically heat from surface water can be caught and used to heat residential areas. Anyway, this was coined in new governance frameworks, the Climate Agreement, Mission WaterWarmth in Friesland, which was also the basis for developing an Interreg proposal on this. And that became the wonderful WaterWarmth aquathermal project with a lot of pilots going on. So there is increased momentum, and now we're basically already constructing. You saw the presentation about Kortrijk and the wonderful pilot they have going on. There is a big momentum with positive energy and wonderful pilots being tested and being monitored and assessed. Outside of the positive things, we did find a couple of governance barriers. So especially in the Belgian pilots, we noted that every heat system, also an aquathermal system, has also spatial implications, and that also calls for planning. So if it has the spatial implications, it's important to coordinate planning between different departments, the one on water, the one on energy, and of course also spatial affairs. And that's seen as a tension in practice. Then in many pilots, we saw a lack of public funds, also addressed by Natabi earlier on, but also bureaucracy. So a lot of civil servants, also those working on permitting, are not aware of this new way of heating, aquathermal energy. And they have strict stipulations, typically in water permit silos. And it also comes with a lot of hassle, a lot of red tape and administrative cost for heat projects, and taking this to the next step, also in permitting. For example, with water boards, we're having restricting permit systems regarding water temperatures, norms, affluents, charging on the water, but also drilling. It all comes with norms, and it becomes a lengthy, complex process with, in the end, either approval or disapproval of the permit. Finally, we also saw a reluctance in accepting aquathermal energy by policy and decision makers, to some extent because it's new, but also because it's highly intersectoral. It's typically a nexus topic that's in between energy, water, spatial affairs, and so on. So in that sense, it touches upon a couple of different institutional barriers, and it requires more mainstreaming. And now it comes to possible solutions. So one way that is important and should be done to take away a lot of uncertainties and a lot of red tape also is to establish something like collective heat acts, also like we have in the Netherlands, and that's an act on collective heat system called collective district heating systems, to say things about ownership, planning, and so on. Importance also, to avoid, let's say, the competition between fossil fuel heat prices and aquathermal heat prices, to remove fossil subsidies. It's a big thing, but it's also important to develop aquathermal energy. But also to cope with a lot of reluctance, a lot of uncertainty and risks that investors see in this new technology. They're not familiar with it. They need a best practice, and going to the bank to get millions to establish a new DH system working on aquathermal energy is of course a big thing. And therefore, we need to have another look on how investors basically can be engaged and can be supported in funding AE technology. And finally, we also advocate for closer collaboration between the water energy agencies and possibly also those in spatial affairs. That's it for now. Thanks for your attention.
Thank you, Thomas. And what is a webinar without any technical issues, of course? I'm not sure if you're seeing the presentation still. Yes, you are. Okay, because the PowerPoint Live was not working anymore. So I'm not sure if our next speaker will be able to take control of the slides. So I will just change them for you. I think it's easier. So to move on, our next speaker is Jade Santier. Jade is a project manager at Builders Engineering School located in Normandy, France. As a part of the WaterWarmth project, she is the work package leader of work package 2 on experimental aquathermal energy pilots. At the same time, Builders is also in charge of the pilot site in Ouistreham, near their premises, where they are experimenting with and improving aquathermal energy using seawater. Jade, I leave you the floor with your presentation on the case study tour pilot sites. Thank you.
Okay, thank you. So I think we can move on. Thank you for the introduction. I think, thank you. So just to have a bit of context, so already mentioned by my colleagues from the project. So in WaterWarmth project, you have 10 pilots, which are 6 small scale that are currently in progress, and 4 large scale for the project. So here today we will be more focused on the small scale, as I'm in charge of the coordination of these. So if we can move on. So in the 6 small scale pilots, so they are distributed into different countries, Denmark, the Netherlands, Belgium, and France. So the first one that you can see above is the one in Denmark, in Middelfart. So that's led by the commune of Middelfart. Then you have the Port Village, which is in the Netherlands, which is managed by the city of Leeuwarden. Then you have another one in the Netherlands, which is the Firma van Buiten, led by TU Delft, which is another academic partners, and then 2 in Belgium, one in the city of Mechelen, and one in hub in the city of Kortrijk that you already saw that Dirk presented earlier in the presentation. And then in France, you have our pilot site, which is located in Ouistreham, that you will see just after. So the innovation part for this experimental pilots is that we use different types of surface water that you will see just because we will have the tour of the different pilots. So if you can move on to the next slide. So just for you to have an overview of the pilots, so you will see the 6. So the first one, so it's our pilot, which is in Normandy, which is like 15-20 minutes driving from our school. So that's why we chose also this pilot, because it was really close to our premises, really easy to collect data. So it's like a school, like a center of nautical activities, which is really close to the sea and which is located in the port area. So for this one, we will use the seawater. This was already done in Normandy, in fact, and in France. We use a lot of the seawater to heat the building. So we will collect the seawater. In fact, the works are already done. I will explain it just after. To heat all the sanitaries and the building. So this is for the French part. And then if we start with the Belgium side, so you have the pilot site in Mechelen, which is the castle of Den Bosch, which is in fact a castle which is in their renovation. So we still are waiting for the answer from the investors of the castle, but the feasibility study is already done. So we've been a bit late with this one because in fact at the beginning of the project we lost one of our partner which was the initial pilot site for Mechelen. So for this one, the type of water that will be used will be all the moats around surrounding the castle. So we'll not use the river, but really the moats, which is another type of surface water, which allows us really to have different, the different types and to see what is the most potential, the most powerful surface water. Then if we move on to the next pilots to continue. So we have the second pilot from Belgium that Dirk already showed the video. So it's the one in Kortrijk that we visited last week, in fact, which is like an academic and residential for the students area. You already have students there. The particular point from this one is that it's like a hybrid system. So you have the geothermal system and the aquathermal system that will be like fed, or the river, the Leia River, which is near the area, will be used to heat the building. So this one is really important because we visited it last week, and we can see that students are already living there, and this was really particular because it's a totally new building. So they had to make it through the calendar of the building and also the installation of the heating and cooling system. But hopefully we will start collecting data like during the winter. And then just after, you have the one in Denmark. Just to explain a bit the situation about Denmark, for political reasons, if we can say that, this was really difficult. The pilot site in Denmark, we had to think about different plans, different situations, because the Danish government was a bit skeptical regarding the use of aquathermal energy. So that was a really whole work and whole how can I say support for the policy. So this one is an assembly hall in a small village in Denmark. I will not pronounce the name because it will be horrible. But for this one, we'll use the water from a pond, which is just near this building. And the idea is to first test it with the assembly hall, and then after, if possible, even with this pond, which has a lot of potential, in fact, we noticed that, it would be to think in a larger view for the whole village. Then we have the two last pilot sites in the next slide. The two next pilot sites, so they are the two Dutch pilot sites. The first one is the one led by Delft, which is the Firma van Buiten that we visited, in fact, last year. So for the moment, it's a temporary location. And for this one, so it's a catering and conference venue. So we could see and we could test it, in fact, last year. And for the type of surface water that will be used, it's all the how can I say, the standing water that is around the building. So that you can see that we really have different type of surface water. And for this one also, all the technical studies are almost done, and we are expecting to collect data for the winter, for this winter. And our last one is the other Dutch pilot. So it's in Bart village, which is a small village in the province of Friesland, in the north of the Netherlands. You have like less than 100 houses. And the experimental part for this one will be to heat 5 houses and a primary school with all, well, we cannot see a lot in the picture, but you have a lot of water in the village. So the idea is to use the water from the village to heat these houses. And yeah, so this is about a bit the overview of about the 6 pilots. It was really quite difficult, and now we're happy to have the 6 pilots, not all done, but at least to have like this overview. And if we pass to the next slide. So about the progress, all the pilots are not yet fully implemented. It means that we're not yet collecting data, but more than the half of the pilots will be collecting data this winter, some before the end of the year and some at the beginning of the next year. We have to know that it's been a real trouble for us, all the experimental parts. I will explain it just after, but finally, after 2 years, we can say that our pilots are almost running. So that's really a blocking point that is now, I hope, gone. But that's a good thing. And almost all permits have been issued. The permits, well, it's just the transition for the next slide and the last one. If we can move on. The permits took us a long time to get it because, as Antavi just mentioned before, we have in this 4 different countries different regulations, different authorizations to obtain, and this has been quite long for us, depending of the different pilots. And it's also because of the first part, the complexity of pilots. For example, if I'm giving just a case study, for the one we have in France, we are in the port area, but we are also located in the city of Wistreham. So we have different stakeholders that we had to take into account and to have some authorizations. And you also have a lot of people around, so you have to take them into account. And this was the same type for almost all pilots, because depending of the regulations, for example, I think it was the Dutch pilot, they had also to ask the water board, etc. So this was quite difficult because we had to prove also that it's good for the environment, if the project is sustainable and that will have a real benefit. So this was the most tricky part. And the second challenge that now we're more and more, how can I say it, exiting from the the project, is all the budget parts, because we have to know that the project was submitted in 2022. And now we are in 2025. Some years have passed and some events also. So the cost of the pilots has increased a bit and the budget. And also we noticed that in the major part of our countries, it was difficult to make like the call for tenders because you don't have that much companies that are doing aquathermal energy. So this was also a point. And when you have less companies, well, when you don't have a lot of choice in terms of companies, well, the prices, the cost will also increase. So yeah, these were the challenge about the pilot. But I hope that in our next event we will be able to also share data with you because yeah, we lost a bit of time during the last 2 years, but now we're quite happy because pilots are almost running. And that's it. That was the overview of the pilots.
Thank you, Jade, for your presentation. We now move on to our last speaker, Len Kusman. Len is an industrial chemical engineer with a postgraduate in innovative entrepreneurship for engineers. He applies his practical and organizational expertise as a project engineer at Extract. And since 2024, he has been dedicated to advancing sustainability through aquathermal energy. Len, the floor is yours with your presentation on the spotlight on feasibility of aquathermal energy. Thank you.
All right, thank you, Martina. So I'll quickly take you through the different steps one typically takes when going from a project ID towards the end of a feasibility study. So you can go to the next slide. And that typically starts by getting inspired by aquathermal energy, which can be either through a site visit, which we provide sometimes, to projects that have been realized already, and hopefully in the future the demo sites from the WaterWarmth project can serve that purpose as well. Another option to get inspired is to when someone encounters potential maps or plans that we, for instance, provided for the municipality of East Flanders in Belgium, or for the not municipality, I mean the province of East Flanders, or for the province of Friesland in the Netherlands, and where you can see which areas are specifically suited for aquathermal energy, and that can generate IDs with people with a project ID. So once that project ID is active or is in the minds of the people, what is then the next step? Martina, you can go to the next slide. We think that the next step is to perform the quick scan, which we have developed in the WaterWarmth project, and which aim is to quickly identify any issues that might arise when you want to implement an aquathermal energy project. So it goes into detail. It's an Excel tool. You fill in your site details. It is made to be done for either a building, or it can be multiple buildings, can even be for a district heating network. The idea is that, yeah, you have certain checks and balances. Sometimes you have to fill in a number. Sometimes you can choose from a drop-down list. In any case, if you go to the next slide, at the end, you will get an overview of what has a green light, and when it says a green light, you can go ahead without worries. Sometimes you will get an orange light, which means that, okay, certain things need to be looked into more in detail, and which might require some next steps. Well, sometimes you get a red light, and a red light means that, yeah, that's a game changer for, or it's a showstopper for aquathermal energy. To give an example is, yeah, if there is no electrical capacity on your project site left to build a heat pump, then that might be a problem. So in the end, if there are enough green or orange flags, you can go to the next step, which is a pre-feasibility study. And that's when you really, as an engineer who performs these studies, go on site to check things. The pre-feasibility study provides an answer to let's say 4 major questions. And the first one is, can we see things that might make the project not feasible, that have escaped the attention of the quick scan user? Because our idea is that a quick scan is something that anyone should be able to fill in to evaluate their own site, whilst the pre-feasibility study is something that is done by an aquathermal energy expert. And that aquathermal energy expert might see things that have been missed by the quick scan, by the person who filled in the quick scan. We also evaluate in a pre-feasibility study things that really need to be studied in detail to make sure that a project is feasible, which can be around all sorts of things like water depth, water quality, thermal impact, you name it. But in a pre-feasibility study, the aim is more to identify these things than more solve them all into detail. Also, a very important aspect of what we see in a pre-feasibility study is that we try to have the first conversations with the public water authorities about a project, to see what they think and feel about what is intended. And that can also be an input for the next steps when, for instance, designing a possible solution. But the main important reason why a pre-feasibility is, in our opinion, necessary is to prevent costs with project owners by ordering a full feasibility study in which you sometimes after 5 minutes see that there are showstoppers, and then it's a pity that you've ordered a very big study while you could actually have gone with a pre-feasibility study and came to the same conclusion. So the pre-feasibility's main aim is to check whether it makes sense to order a full feasibility study. On the right of this slide, you see some aspects that are covered in a full feasibility study. We plan to make a more detailed webinar specifically about all the different aspects of the pre-feasibility and feasibility study. So if you just follow the LinkedIn page of EHPA and or other channels by which you've stumbled upon this webinar, you will most definitely get the invitation to that other one. Okay, can you go to the next slide, please? So once your pre-feasibility says that there is actually some potential for aquathermal energy and there are no major reasons why not to go to a full feasibility study, then you can go ahead and have an aquathermal expert go to the bottom of things. Because what we see in a feasibility study is that there are 4 major parts, and one of the most important parts is what the thermal impact on the water will be. In a lot of countries, there are certain limits about how many degrees of temperature difference you can create by doing an aquathermal energy project. So that's something that we will always try to study in detail. So the movie you see on the top of the slide is actually a detailed analysis of locations where a thermal impact is being generated and the maximum temperature decrease it generates. The second part of the feasibility study is all about what the technical concept can be for aquathermal energy, but often in a feasibility study, it also includes other technologies, other green energy technologies. Sometimes fossil fuel backup systems are also included, but we try to avoid that, of course. So that part of the feasibility study really tries to find the optimal solution for the technology, which is not always 100% aquathermal energy. It can be also a mix, a combination of different technologies. And then the third part, crucial before going to the next phase, and that is to have some sort of pre-agreement from the water body authorities that the water body can be used, that the concept you have designed in phase 2 is also to their liking, and if not, that you can make some alterations so that it is to their liking. Once they have given their sort of pre-agreement, or sometimes it even in this phase already goes towards a full permit request, then yeah, I think that the question that all project owners will ask is, okay, what's the financial situation of this project? If I invest into aquathermal energy, will I save money in the end? So yeah, mostly that's the main aim of someone who orders the feasibility study, but you cannot get an insight into the financial situation with all the above steps. So that's usually why it comes at the end of the feasibility study, and which is, let's say, the most important thing that the client will always remember. All right, so at the end of a feasibility study, if all the lights are green, there are no if the public water authority agrees, if your financial situation looks all right, then you've reached the end of the feasibility phase, and you can go towards project development, which is on the next slide. Oh no, first, yeah, the theory about what is a pre-feasibility study and a feasibility study is we've made documents that go into detail, which we call product sheets. They can be used for someone looking for these kind of studies to evaluate if they get an offer from a party to see is everything included that should be included, or they can even use this document to prepare a tender for a pre-feasibility or a feasibility study. These documents can be downloaded on the same page as the quick scan tool if you are interested in that. Okay, next slide, please. And this is the last slide and the last phase of the feasibility trajectory. So once you've reached the positive result of a feasibility study, you will try to typically go to financial close, and all the steps that are in between the end of the positive feasibility study and the financial close, that's something that will be worked on by the Work Package 2 and Work Package 3 team to specify a roadmap, all the things that could happen and need to happen to get towards realization. So yeah. So I've reached the end of my journey, and if you have questions, please put them in the chat and then I can answer them.
Thank you for the presentation, Len. As you mentioned, it's now time for our Q&A session. So I'm just checking. So in the Q&A section of the webinar, I currently see two questions. One is from Jeffrey Van Dijk, and it's addressed to Dirk. Yeah, this is more of a, let's say, collaboration inquiry. So maybe it can be addressed privately. But we also have another question still for Dirk, and it's from Hannah Melling. And she asks if you could clarify how you calculate the economic and socioeconomic potential, and which variables or indicators do you include in this assessment. I think that Len, I think you replied with your presentation to this question, but I might be wrong.
Yes, sort of, but I think that this might also be about work package 5.
Okay.
Calculating the economical impact or the potential of this technology. And I don't know if you want to go into that, Dirk, or should I continue?
Yeah, so obviously you're the expert, Len, because you're the ones doing calculations for the economic potential study. So if I'm wrong, please correct me or add. But what we do with the economic potential is that we, first of all, look into what is the potential for a certain area in terms of looking at is there a source nearby? What's the capacity of the source? And is there an area of houses nearby? Is this more feasible for individual connections or for a larger district heating system? So that's one aspect, and we base that on a certain amount of open source databases, for instance, hot maps from the EU. And second of all, then we look at the energy market prices for gas, for electricity, for oil, as far as these are available, of course. I know for electricity and for gas, they are publicly available. They had prices, spot market, and so on. So in that terms, we do a comparison study between the different sources, and we also look into the availability of the source in certain areas, for instance, lakes, canals, ponds, coastal waters even. And then look also towards, is there a certain amount of demand within, for instance, 500 meters from this kind of source. Have you anything to add, Len? Because that was quite a short overview.
Yeah, maybe. So what we have calculated is actually a true potential of aquathermal energy on a technological level, which means that we connect the let's say the heat potential of rivers, lakes, the sea, to where existing heat demand is. And then we get a number of what actually is possible in certain areas. And indeed, then we translate that to the economic potential by using cost calculations for both the investment as the operational expenses. And we try to see what the difference is between existing technologies. So I hope this answers the question a little bit.
Thank you both for your replies, and I'm sure if it's not clear, maybe Anna can follow up with another question. But in the meantime, I have 2 questions for Natabi and Anne-Sophie regarding your presentation. So is there a particular barrier or success that resonated with you as the research team? And also, is there a way to address these barriers for a better implementation?
Okay, I'll go first. I think for me, the biggest barrier is that of funding or the financial barrier, because everyone, spoke about it. It was so difficult to get financial guarantees, just to have the financial backing. And that's because the implementation of aquathermal energy systems is quite expensive. It's not a cheap technology. it needs quite a lot of money. So you need quite huge investments, but it doesn't mean that it's not possible. There should be willingness at all levels, political, funding, finance. I think all levels should be part of it. So yeah, like I said, it's also not impossible, because where all of these elements come together, where there is flexibility and willingness to fund, then you see things happen and shift. Yeah. Also, another one I think is the policy one. I think once you have willingness from the political level, in terms of also making sure that this is part of their agenda. So when you think of the Aquathermal Green Deal and how all those stakeholders came together, and it shows that there is a level, I'm talking about the Netherlands here, there is a level of willingness also at a political level to be open to a discussion and a conversation about this technology, given what is happening around us in Europe and the state of energy, and how countries have to be independent in terms of and collaborate actually also on renewable energy technologies. So this is also quite important. I think for me, yes, the most important are the finance and also the policy and regulations. I don't know, Fia, maybe you have something also to add.
What I wanted to add is you can tell that Natabi and I work in the same work package, because I also wanted to say finances, but the only point I would add on to that is that if you remember, I discussed in the workshop how we use it to validate the results and find new patterns. And within our workshop, we found again and again in current barriers, it was again finance across all regions. So it was finance issues in various places. So I also think it can be addressed in policy. Another point that I think Jade made was permitting issues, because these are all finance maybe across all of Europe, but permits are so specific to the country and also an issue. So I would say policy and finance as well. Thank you.
Thank you for your replies regarding this. I was also wondering if these barriers have shown themselves in at the same time in combination. I guess that when there is a combination of different barriers showing up, then it even gets more complicated. So I was wondering, even Thomas, you can jump in, of course, if there are specific policy interventions that can be done to sustain the development of such projects.
Yeah,
Yes, Thomas.
if you may let me jump in, two things I would like to address. So we addressed a range of governance barriers. I would say it's governance barriers. It goes beyond regulatory barriers. There's also a lot of coordination, organization, and finance, and community in it. But it's not that all these different barriers that they operate in silo, that they are separate. What happens in practice is that they are interlinked, and they are highly depending on each other. For example, what we saw with the WaterWarmth pilot was there was a coincidence of 5 of these different barriers that we observed. First of all, more investment was needed, especially with regards to coping with the risks. And then it was different to find, let's say, private sector investors. So they had to come up, and it was basically drawn by an energy community who got in partnership with government and others. And already started making also contracts planning, also with contractors, etc. But the important thing was they needed a guarantee to make the investments. And therefore, they were depending on the municipality, local government, which basically said, we will give you the guarantee if you can assure us that you are going to get approval of 80% of the households of the village. And they were quite confident we're going to make it. But then there was the barrier of awareness, and which turned out to be a reluctance among, let's say, nearly 60% of the households in the village. And they couldn't get over 44% approval of the households, so that they were far from reaching this 80% threshold. And after this turned out, a year later, the municipality said, well, you did not meet 80%, only 44%. So a minority of the citizens, of the households in our town, allow you, have trusted that you're going to make this aquathermal collective system. So we cannot give you, let's say, the financial guarantee that you need. So hence they could not get the investment. And for a while, that basically shut down the project. So right now, they're looking for a startup. But what they found, that coordination with the municipality, but also engagement with the local inhabitants, with the residents, with the households, to make them aware and persuade them about the benefits of aquathermal energy and collective heat systems in general, was quite a big challenge. So here you see this confluence, this interconnectedness between barriers that became a big hurdle, and in the end led the project to be terminated for a while. So that's how complex it is in society, and therefore you need good planning, but also good funding in place, and also to think in terms of how do we address risks for investments? What can we do to come up with, let's say, a financial guarantee that make this project work? So perhaps we can think about a big green funds, maybe even at the national level, for big projects that take millions and millions of dollars, especially the collective district heating projects, to address this. But it's also important to raise awareness, to make people aware, to make households aware, but also to train civil servants and others, and to build capacities to basically develop, support, and provide guidance to these very complex projects. And furthermore, I would say, please continue governments with providing subsidies for these to learn and scale these aquathermal energy projects, both production subsidies like SDE++ in the Netherlands, but also upfront subsidies for heat pumps and other equipment. And also learn from this, to create partnerships, create networking conditions, so that best practices can be shared and that knowledge is gained, and we're not going to reinvent the wheel in individual projects.
I maybe would like to add something that is an important insight, that a lot of the barriers that are mentioned, especially in larger scale projects, are not specifically about aquathermal energy. Especially like the last things you mentioned, Thomas. There's something that, yeah, of course, all renewable energy sources have to put up with. So, but of course, if we pull up the whole group of renewable energy technologies, then aquathermal energy can follow in those footsteps, of course.
Yeah, I was going to say that working with European projects, especially in the Horizon and LIFE program funding, whenever you have pilot sites, there are always complications due to regulatory barriers, costs that change throughout the years, because you present the project 1 year, but then the years go by and there's the inflation, so they change. And yeah, these are all challenges that are shared among renewable energy pilot sites, as you mentioned, Len. We just have follow-up questions from Hannah. She specifically asks, what costs do you assume for the technology of aquathermal heat extraction? Since there are not many companies producing this kind of technology in larger scales, it's hard to get a realistic idea of investment costs.
Mm-hmm.
I think it's open to, yeah.
I'm not sure about the specific numbers, but I can tell you what they are based on, because yeah, we are experts in the aquathermal energy field. We have done different projects, and so we've provided our insight from existing projects and also from just market analysis to see how much component costs are. And so we have a general idea, let's say, in sort of for small projects, for semi-small, for large projects, for medium projects, what the costs will be, and we've added that as an insight to the work package 5 responsible. So they're based on practice, let's say.
Thank you for addressing that, Len. I don't see any other questions from the audience. And so I think it's now time to end our webinar. In the upcoming days, you will all receive a follow-up email from me with the recording and the presentation that was shared today. And thank you all for attending. And as I mentioned before, please, you can follow the social media channels of the project, but also of the HPA to stay connected and yeah, not miss any updates from our side. Thank you, everybody. Have a lovely day.